Hello again, welcome to another lesson in Algebra 1. Today we're covering section 12.4, Simplify Rational Expressions. We covered these notes in class, however this is here in case you need to go back and refresh your memory or if you were absent that day. Alright, our warm-up says factor each polynomial. So our first one's x squared plus 8x plus 15. Notice the leading coefficient is 1 here, so this makes the problem much easier. We do our little x, we put what two numbers multiply to 15 and add to 8, and those numbers are 3 and 5. So since we have a coefficient of 1, we don't have to do the box. We can just go right to our answers, x plus 3 and x plus 5. In number 2, we do our little x here. We put negative 16 on top. Remember, that's the a and the c multiplied together. And we put 15 on the bottom. These two numbers are going to be negative 1 and positive 16. However, we don't have a leading coefficient of 1 this time, so we have to make our box. So we put 2x squared here, we put the minus 8 down in the bottom right, and we split the 15x into 16x and minus 1x. All right, so on the top row, we can factor out 2x out of the two inside ones, and that leaves behind x and 8. Okay. Down here, I need a negative 1. So negative 1 times x will make negative 1x, and negative 1 times 8 will make negative 8. So this will factor into 2x minus 1 and x plus 8. All right, new stuff. A rational expression is an expression that can be written as a ratio of two polynomials, where the denominator is not 0. So since we can have expressions on the bottom, we have to be careful. Sometimes values of x will make the denominator be 0. When that happens, we consider these excluded values, x's that aren't allowed in our expression. So for instance, in this expression, x equal to 3 is undefined, so 3 is an excluded value. Let's see what happens if we plug in 3 here. We end up with 2 divided by 0, and we know that this is undefined. Okay, that's why x is an excluded value. All right, so first direction, say find the excluded values of any of the expression. Okay, so we want to look at each expression and decide if any of those have excluded values. Well, the only thing that could make excluded values is the denominator. So we never want the denominator to become 0. So all we have to do is take our denominator, set it equal to 0, and solve it. So this would be 5/3. So if 5/3 was plugged into this, the denominator of this fraction would be 0, and that would be bad. So our excluded value is 5/3. Okay. Number 2 is a bit trickier. This is 5y squared plus 2y plus 3. We could try to see if we could factor this. So 15 and 2. Two numbers that multiply to 15 and add to 2, they don't work. Okay, there's no numbers, so it's not factorable, so we have to go with some other method to try to solve the bottom equal to 0. So 5y squared plus 2y plus 3 equal to 0. I think the easiest method would be our quadratic formula. So negative b would be negative 2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 5's value. Okay, so this will give us y is equal to negative 2 plus or minus something over 10. And this is where a calculator comes in handy. So I'm going to pull out the calculator and do 2 squared minus 4 times 5 times 3. It's going to give me negative 56. Now, I know that if I try to type in the square root of negative 56, it's going to give me an error message. So this parabola, if I was to graph it, never crosses the x-intercept. So there are no solutions to this. Okay, this has no solutions. Therefore, there are no excluded values. No matter what value I pick for y, the bottom will never be 0 in this fraction. All right. Number 3, we have n minus 6 over 2n squared minus 5n minus 12. So once again, we don't want the bottom to be 0. So we just set it equal to 0 and try to solve to see if there's any excluded values. If I do my little x here, this is going to be negative 24 on top and negative 5 on the bottom. and that would factor to negative 8 and 3. So I can do my box here. I don't have to resort to like the quadratic formula or something like that. And we're going to put 2n squared, negative 12, and then we'll split that into negative 8n and positive 3. So 2n can be factored out. It leaves behind n minus 8. And, oh, I'm sorry, n minus 4 here. 2 times 4 to make 8. And then I need a 3 down here. So 3 times n will make 3n, and 3 times minus 4 will make negative 12. So that works. So this would factor into n minus 4, 2n plus 3 equal to 0. You can solve each one separately. So from the first one, we'd get n is 4. And from the second one, we're going to get n is negative 3 halves, okay, or negative 1.5. So my excluded values are 4 and negative 3 halves. If we plug those in for n, then the bottom of our fraction will become 0. All right. Number 4, same kind of thing. M squared minus 4, we'll set it equal to 0 because these are the things that aren't allowed. We solve this. And I square root both sides, and I'm going to get plus or minus 2. So my excluded values are 2 and negative 2. Okay, on our second page, we have a little blurb up here called Simplifying Rational Expressions. To simplify a rational expression, you factor the numerator and the denominator and then divide out any common factors. So be careful, binomial factors may only cancel with other binomial factors and monomials with other monomials, etc. We'll see that in the problems in a minute. Okay? So a rational expression is in the simplest form if the numerator and the denominator have no factors in common other than 1. All right, so if we look at the first one here, simplify the rational expression if possible, but we need to state excluded values. So our excluded values are still going to be found by taking the original denominator, setting it equal to 0, and solving. So 0 is not allowed. So we have an excluded value. Okay, so my excluded value is 0. That's not allowed. But this fraction does simplify. The two x's will cancel each other out. So the simple version of this fraction is actually 2/3. Now you say, well, but what does it matter if there was an excluded value? And the excluded value comes from our original problem. Okay? If I take our original problem that's not been simplified yet, and I plug in 0 for x, I end up with 0 divided by 0. And this is undefined. And that's why we have an excluded value, even though the simplest form of this, it doesn't have any variables at all. All right, number 6. On top, it's already factored. 6 times x, a monomial, can't be broken apart anymore. The bottom's already factored. They factored out a common monomial of 6. And then we can cancel the 6's. And we're left with x plus 5 underneath of x. Now, a lot of people will try to cancel the two x's out and make this 1/5. But be careful. Monomials, which is what the top is, will only cancel with other monomials. And the bottom, which is a binomial, will only cancel with other binomials. Okay? So we cannot cancel this anymore. This is the simplified version. So x over x plus 5 is our simple version. And we do have an excluded value. The excluded value comes from taking the bottom, remember, and setting it equal to 0. And in this case, we could divide by 6 and get x plus 5 as 0, and then subtract 5 to both sides. So our excluded value is negative 5. Okay, there's our second answer. All right, number 7, we have 8b squared plus 16b over 32b squared. So I'm going to factor the top here. There's a common factor of 8b left in there, and that leaves behind b plus 2. Okay. The bottom has 32b, that's monomial, so it's already factored. Now, of the two monomials, these two right here, we can cancel the b's out, okay? And 8 over 32 will reduce to 1/4. So this, in simplified version, is b plus 2 over 4. Do not try to cancel the 2 and the 4. Remember, binomial up top, monomial down below. They don't cancel together. And that's because of the order of operations. This big bar is a grouping symbol, so we have to do this before we can divide by 4. Okay? All right, we do have an excluded value. It's easy to see this one. It's 0 again. Okay, if b was 0, our original fraction would be 32 times 0 on the bottom. All right, number 8, this is already simplified. It will not get any more. A over 1 minus a. Okay, this is as simple as it gets. And then we got an excluded value, so 1 minus a equals 0. We solve for a. Negative a equals negative 1, so a can't be 1. So here's our simplified version, and our excluded value is 1. Okay. Number 9, 3x squared plus 8x on top and 3x plus 12 on the bottom. On the top, only an x can factor out. That leaves behind 3x plus 8. And on the bottom, a 3 can factor out, and that leaves behind x plus 4. So there's no common monomials, there's no common binomials, so this original fraction was as simple as we can get. There's our rational fraction, our rational expression simplified already. Okay, our excluded value is going to come from taking the bottom, setting it equal to 0, and solving for x. So x is negative 4. So our excluded value is negative 4. All right. And then in our last one, the top is already factored, but the bottom I can take out a factor of 8x squared. It leaves behind x plus 2. And then the monomials can be simplified. The 8's can cancel. This x will cancel with the squared, so now we're left with 1 on top and x times x plus 2 on the bottom. We're going to go ahead and multiply that back together. So x times x is x squared, and x times 2 is 2x. So here's our simplified fraction. Okay, and then the excluded values, let's see. We could factor out 8x squared, just like we did before. X plus 2 equal to 0. So this one's going to give us an excluded value of 0. And over here, we're going to get an excluded value of negative 2. So x plus 2 equals 0, so x equal to negative 2 is going to be our excluded value. Okay, so negative 2 and 0 are our excluded values. Okay, for our last directions, we have simplified the rational expression, state the excluded values. So the only difference is the if possible part from above. So all these can be simplified or maybe not, but they're not giving you a hint that they might not be able to. All right, so our first one, we're going to try this with factoring first. So two things that could multiply to 12 and add to negative 7. And that would be negative 3 and negative 4. So we could simplify this into x minus 3, x minus 4. And then in the bottom, that's a difference of squares, but I really want the x to be first. So I'm going to change this into negative x squared minus 16. And then I'll factor that into negative x minus 4, x plus 4. Okay? Then it's easier to see that the x minus 4s will cancel out. So our simplified version here is going to be x minus 3 on top, and then we multiply the negative back in, so negative x minus 4 on the bottom. Okay, that's our first answer, simplify the rational expression. And then we need to state excluded values. Our excluded values are going to be found from the factored version, setting the bottom equal to 0. So this part, we can just pretend like it's equal to 0 on the bottom here. And it's easy to see the two answers that aren't going to be excluded. One of them is going to be positive 4. That'll make that guy be 0. And the other one would be negative 4. That'll make the second one be 0. All right. Number 12, same kind of thing. Start with simplifying first. So two numbers that multiply to 2 and add to 3 are 2 and 1. So that top one's easy to factor. And on the bottom, two things that multiply to 10 and add to 7. That's going to be 2 and 5. Both of these have leading coefficients of 1, so I didn't even make the x to see what they were. I just said, what are things that multiply to 10 and add to 7? All right, so you can see now these two binomials are the same, so they cancel out. And our simplified version is x plus 1 over x plus 5. Remember, we cannot cross out the x's here because this is a binomials, and binomials will only cancel with other binomials. So x plus 1 could only cancel with another x plus 1. Okay. We do have excluded values, so look at our denominator and think of it as set to 0, and you would see that negative 2 won't work, and negative 5 won't work. All right. Number 13, factor the top. So this is y plus 8, y minus 8. That's a difference of squares. It's worth memorizing, going back even if you haven't done it yet. And then on the bottom, this is a perfect square one. So this is y minus 8 squared, but I'm going to go ahead and write it out twice. It's easier to see how we only cancel one of them. So our simplified version for this rational fraction, or rational expression, is y plus 8 over y minus 8. And the excluded values are all of the numbers that would make the bottom be 0. So in this case, from here we would get 8, and from over here we're going to get, well, also 8. So 8 is the only one. Okay. All right, last one. Let's see. The bottom here was going to factor into z minus 5 and z plus 2. Negative 5 and 2 are the two things that multiply to negative 10 and add to negative 3. And on the top, I'm going to rewrite this, so I'll take a negative out so I can get my z squared first. So I'll just change everybody's sign, z squared minus 4z minus 5. And then that's going to give me negative, and then two things that multiply to negative 5 and add to negative 4. Well, that's z minus 5 and z plus 1. All right, that's easy for us now to see that the z minus 5s will cancel out. So our simplified fraction will be negative z minus 1 over top of z plus 2. Once again, these are binomials, so they can only cancel with binomials that are exactly the same, so no canceling left here. This is a simplified rational expression. And then our excluded values are going to be any z's that would have made the denominator become 0. And it's easy to see that here a 5 would be excluded, and over here a negative 2 would be excluded. All right, this concludes our notes. The homework was page 797, 3 through 36 multiples of 3. That's 12 problems because you do have to do factoring and stuff inside of the problems. All right, I'll see you next time in class.